Good morning, this is Mr. Precella, and today in this short video we're going to begin discussing solving equations. That's a major part of algebra. And first of all, what is an equation? Well, an equation is an algebraic expression that contains an equal sign. I mean an equal sign in the original statement of the problem, not an equal sign you just stick in as you're working out the problem. For instance, in an earlier video, we were doing the distributive property. Notice how I put the equal sign. That's not an equation. This was the original problem. There was no equal sign in the original problem. Okay? If you just put equal signs as you're reducing something, that's not an equation that you're solving. To solve an equation means to find the number, or possibly numbers, maybe more than one, that make the statement true when substituted in for the variable. So, first thing we're going to do is look at an equation, and I'm going to give a number, and we'll see is that the solution? Is that a solution? Here's this example number 1. Is 27 a solution to this equation? 10 minus x equals 17. It's a tricky one. Okay. 27 would be a solution if we get a true statement when we plug it in for x. If I put a 27 right there for x, be careful, don't immediately say, yes, it is a solution. If I put a 27 there, equals, that's a question mark, by the way, right there. Not a math symbol, it's answering the question, okay? Before you immediately say yes, is this a true statement? 10 minus 27 equals 17? What does 10 minus 27 equal? It's not just 17, is it? It's negative 17. So, is negative 17 equal to 17? No. Okay? That is not, 27 is not a solution. Okay? Let's see, let's do another one. How about this one? Is 30 a solution to this equation? 3 halves t equals 45. Oh, you might be thinking, oh, you don't like fractions. Well, okay. Well, here the variable is the letter t. So let's see, if we put a 30 in for t, is that going to give us 45? Let's see, so I'm replacing this t with a 30. So we have 3 halves. Now what's the operation here? It's times, right? Times, in place of that t, I'm going to write 30. Does it equal 45? Well, I'm going to write that 30 as 30 over 1. Okay. Let's do this multiplication and see. Do we get 45? If we get 45, the answer is yes. If we get anything other than 45, the answer is no. Let's see. Do you remember how you do this cross multiplying? 2 goes into 30 15 times. 3 times 15. Is 3 times 15 45? Yeah. We're getting a 45 on both sides. So, yes, 30 is a solution. And just to make sure you're following this, let's see if I can write out a sentence to try to explain it. 30 is a solution because why? Why is 30 a solution? Replacing t with 30 yields the same number on both sides. In other words, it's a true statement. Up here, when we got negative 17 and 17, no, that's not a true statement. Okay. Let's see, maybe we've got to do one more. Is 1 a solution to this equation? X plus 2 equals 4 minus x. Again, a question mark. This is one of those yes or no questions. Is 1 a solution? Well, this one's a little bit more involved because we have 2 different x's. Let's replace both of those with a 1. What are y'all thinking? This is a good example. Are we getting the same number on both sides? What are y'all thinking? 1 plus 2 equals 4 minus 1. Is this a yes or a no? Yes, it is a solution. Right. Okay. So we know how to find how to determine if a number is a solution. But how do we actually find the solutions? Well, that's a major part of algebra. And let's see if we can do one. Let's find, I'm going to write one. Let's see if we can just figure out the solution. Okay? This is going to be called number, how many examples have I got so far? 3, so here's number 4. Suppose we were told to solve this equation. X minus 5 equals 22. This is an equation. It has an equal sign. And when it says solve, our answer is going to be x equals a number. That's what we want as our answer. Well, the way we're going to go about this is we're going to develop some little properties that we can use for solving equations. Ultimately, what we're going to try to do is isolate the variable. Try to get the x by itself. Our goal will be to rewrite this equation until we just have x equals some number. Once we have x equals a number, there's the solution. How will we do this? Well, by doing the opposite operation. If I want to get this x by itself, the opposite of subtracting 5 would be adding 5. Look what I'm doing. In order to keep this equation equal, if I add 5 to the left-hand side and add 5 to the right-hand side, notice what's happening with these minus 5s. Those are gone, leaving just the x equals 22 plus 5, 27. There's our solution. And you could check your answer by actually plugging it in. 27 minus 5, is that a 22? Well, yes. What we're doing here is called solving equations, and what we've just used is called the addition property. You can add any number you want to both sides of an equation, okay? And why did we add 5? Because we're trying to get the x by itself. You do the opposite operation. How about this one? Solve this. X plus 16 equals 33. And I should mention, this is using what's called the addition property. You can add any number you want to both sides of an equation. Well, if you look at this one here, if we want to get the x by itself, the opposite of adding 16 would be subtracting 16. And you might say, well, wait a minute, you said it's addition. Yeah, but subtracting 16 is the same thing as adding a negative 16. That's what's called the addition property, not the subtraction property. But are the 16s gone now? Well, yeah, 16 minus 16, that's gone. And on the F, we have x equals, is that a 17? You're using Pearson MyLab, there'll be a box where you type the 17 in for x. What we're doing is isolating the variable by doing the opposite operation to both sides. Let's see, here's another example. And again, I'm just numbering these examples so it's easier to tell when I go from one problem or one example to another. I also try to circle the answer so you know when it's that I'm finished. Okay? Let's see. How about this one? Negative 10 equals x plus 7. Oh, that one looks sort of strange. Normally students like the x's on the left, but there's really no reason why it can't be on the right. Now, why am I saying this? Well, if I want to get this x by itself, that means I need to get rid of this plus 7. The opposite of adding 7 is subtracting 7. Now the 7 minus 7, those are gone, leaving just the x on the right. And what number do we have on the left? Be careful. Negative 10 minus 7. Well, that would be negative 10 plus a negative 7. That's a negative 17. And you would type in negative 17 as your answer. Okay? Notice how negative 17 equals x. This is the same thing as x equals negative 17. You don't have to always have the x on the left, although students generally like it on the left more, but sometimes it's on the right. Okay? It's this number that's important, and that you're getting the x by itself, what's called isolating the variable. Number 7, negative 3 plus x equals negative 17. Well, I want this x by itself. So, what will I do here? Should I add 3 or subtract 3 from both sides? What would, get rid of this 3? Well, add 3. If I added 3 to both sides, negative 3 plus 3 would be 0. Now, I should mention we just want a positive x, and that's what we have now, so I don't need to write that plus. Negative 17 plus 3. To add a positive and a negative, you subtract and take the sign of the bigger. So negative 14. Well, we need to do one with fractions, just to see if y'all remember how to add and subtract fractions. How about this? X minus 4 over 5 equals 6 over 7. Yeah, these nasty fractions will pop up every now and then. The principle is still the same. We got to get the x by itself. So what would I do to both sides? Well, how about add 4 over 5 to both sides? Then the 4 over 5s are gone. And let's see, how do I add 6 over 7 plus 4 over 5? Well, I need a common denominator. And what's the smallest common multiple? The multiples of 5. 5, 10, 15, 20, 25, 30, 35. That is a multiple of 7. So 35 would be the common denominator. And y'all remember how to do this? How to get the top here? We're building equivalent fractions. 7 goes into 35 5 times. 6 times 5 is 30. 5 goes into 37. Pardon me. 5 goes into 35 7 times. 4 times 7, 28. Now, once you have two fractions with the same denominator, you just keep that denominator and add the numerators. 30 plus 28 is 58. So 58 over 35 would be our answer. I'll write it over here. Okay. Maybe we better do another one with some fractions. Okay. Okay. That was number 8. Let's do another one with a fraction. Number 9. Negative 1 over 6 plus, usually we have variables of y, but of x, but it doesn't have to be x. So here I'm going to use a different letter. How about a y? So our answer will be y equals some number equals negative 2 over 5. This is called the addition property for solving an equation. Well, to get this positive y by itself, I would need to add opposite operation. Add 1 over 6 to both sides. And over here's my scratch paper. We have a negative 2 over 5 plus 1 over 6. Well, we need a common denominator. Okay. 5, 10, 15, 20, 25, 30. Would 30 be the common denominator? Five goes into 30 6 times. Negative 2 times 6 is a negative 12. 6 goes into 30 5 times. 1 times 5 is 5. And let's see. Keep that 30. And combine the numerators. Be careful. Negative 12 plus a positive 5. To add a negative and a positive, you subtract, take the sign of the number that's bigger in magnitude. Negative. Okay? So negative 7 over 30. Okay? Negative 7 over 30. This is called the addition property. Okay? Addition property. You can add or subtract any number you want to both sides of an equation. Okay? Now, also, the goal is to isolate the x. Okay? Now let's look at this problem. Number 10, right? Have I done 9? Yeah, okay. Number 10, 2x equals 12. Oops. How does this problem differ from the other ones? Well, it is very different. What's the operation going on here? When you just have a variable and a number attached and there's no plus or minus in it, the operation that's going on is multiplication. Over here, we were using adding and subtracting. But on this one, we got to get the x by itself. What operation would undo multiplication? Well, division. If I subtracted 2, that wouldn't actually do anything because 2x minus 2, those aren't like terms. The opposite of multiplication is division. We're going to divide both sides by 2. When we do that, the 2 divided by 2 is just a 1. And we don't need to write coefficients of 1. We'll just write x equals 12 divided by 2 is 6. X equals 6. You'll see perhaps this problem, it might say solve, or it might say solve using the multiplication principle. And you might say, well, wait a minute. We're not really multiplying, we're dividing. Yeah, any sort of division, dividing by 2 could be thought of as multiplying by a half. Okay? So rather than having to call it the multiplication and division principle, it says you can multiply or divide both sides of an equation by any number you want. Why did I divide by 2? Well, check this and see. If you plug a 6 in here, is 2 times 6 equal to 12? Well, sure. So we're doing the opposite operation to isolate the variable. Let's do another one. 11. 36 equals 4x. Oh, here's one where the x is on the right. Okay. What would I do to get the x by itself? Well, you're not going to subtract 4. Subtracting 4 would get rid of this 4. 4x minus 4? No. You can't combine those. But you could divide both sides by 4. Dividing by 4, we have the 4 divided by 4 is a 1. And we'll just write that as x. 36 divided by 4 is 9. Oops. You don't type in, if you're using my line, you don't type in x equal. What you type in is just the number 9. That's why I'm circling just the 9. At this point, it might be a good idea to compare and contrast these two problems. How does this problem differ from number 11? If I want to solve this for x, isolate the x, well, I need to subtract the 4 here, not divide it, okay? This is addition over here, so I can subtract 4 from both sides. Okay. And on the right, the 4's are subtracting out. 4 minus 4 is 0. We just have that positive x. And on the left, a 32. Y'all see the difference here? If there's no symbol between the number and the variable, that's when you divide both sides. Okay? Let's do another one. Better stick with this same black pen. Lately, my pens have all been going dry, so if I have one that's working, I better just leave it like that. Negative x, oh, this is a good one, equals negative 46. Well, our answer should be positive x. Okay, so I'm showing you what to do if you have a negative in front of the x. You're going to treat that as if there's a 1 right there. And then what's the operation? It's negative 1 times x. So divide both sides by negative 1. And negative 1 divided by negative 1 is a positive 1. So on the left, we just have an x. And what do we have on the right? Negative 46 divided by negative 1. Positive 46. Now, remember how to divide fractions. If you're trying to divide fractions, a over b divided by c over d, to divide fractions, you flip and multiply, change the division to a multiplication, and then flip this way. You may have seen a video you may have reviewed dividing fractions earlier. Okay. AD divided by BC. When I'm writing this formula, or making this video right now, this semester, students had a video reviewing multiplying and dividing fractions before they got to this point. So let me show you how you would solve something like this. 3 over 11x equals 18. 3 over 11x equals 18. Oh, well, I need to, that was my phone that went off. I'm sorry about that. Recopy it to show y'all what I'm going to do. Instead of saying divided by 3 over 11, I'm just going to flip and multiply. To get this all to cancel out and give me just a 1, I'm going to say times 11 over 3. This is called multiplying both sides by the reciprocal. When I do that, y'all remember how you can cross cancel? The 3's cross cancel, the 11's cross cancel, leaving just an x. Now, if you want to think of this as 18 over 1, ooh, I don't have a calculator right here in my hand, so I'm not going to multiply straight across. I'm going to do the cross canceling. 3 goes into 18 6 times. 6 times 11. Is that just going to be a 66? Okay. Let's see what you do. Cancel out this fraction. There's multiplication here, so we're dividing. But in order to divide, I'm skipping straight to the multiply by the reciprocal. Okay? Instead of saying divided by 3 over 11, I'm saying times 11 over 3. Okay? Here's another one. Problem 15 of, let's see, negative, that's a negative sign. Let me put the rest in blue. X over 4 equals 9. Well, we want to get that. We want to get this x by itself. Okay? We don't want the negative, and we don't want this 4 here. We're isolating the variable. Well, we can make it into a couple of steps if you want. The first would be, okay, to get rid of this 4, it's divided by 4. Let's multiply both sides by 4. And when we do that, 4's gone. Let me go ahead and write what we have remaining. It's sort of messy. Negative x equals 9 times 4 is 36. You might think, okay, so I'm going to type 36 in for my answer. No. This is negative x. We just want a positive x. So what did we do over here when there was a negative in front of the x? You divide both sides by negative 1. Divide both sides by negative 1. And what number are we going to type in as our answer if we're using Pearson MyLab? 36 divided by negative 1 is negative 36. Okay. Oh, trying to keep these videos a little shorter. Sometimes I have videos that are 90 minutes, and that's probably too long for y'all to sit with. But let's see if I can do one more example. See if I can get it done right here. Problem number 16, or example number 16. Instead of this x over 4, sometimes the way you see it is written like this. Negative 1/2 x equals, negative 5 over 6. Negative 1/2 x equals negative 5 over 6. I'm going to recopy the problem so it doesn't look quite so messy as I'm going through. So you can look back at the original problem. I want this x to be completely by itself. So I need to get rid of the negative, and I need to get rid of this negative 1/2. Well, if I just did the idea of multiplying by the reciprocal, flipping 1/2, I'd get a 2. If I multiply both sides by negative 2, is everything over here going to cancel out and leave me just a positive x? Well, negative times negative is positive. These 2's cross cancel, leaving me just a positive x equals, negative times negative is positive, 10 over 6. Oh, but I need to reduce that to what? Divide above and below by 2. 5 over 3. Okay. Any questions there? multiply both sides by the reciprocal. The reciprocal of negative 1/2 would be negative 2 over 1, or just negative 2. Sometimes students only multiply by 2, but if you do that, you're going to still have this negative here. Okay? So what we're doing here is solving equations using the addition principle and the multiplication principle. Okay? So thank you for watching the video, and I hope you're having a good week. This is Mr. Precella saying bye.